Point P is situated at the base of a smooth plane, which is at an angle arctan 3/4 to the horizontal. A body is projected from P with a speed of 12 meters per second up the line of the greatest slope and first comes to rest at Q. Find the distance PQ. So, like all good mechanics problem or modelling problem, we need to draw a diagram. So we've got a slope. So the angle here is actually arctan 3/4. Arctan means tan to the -1 of 3/4. We got our initial body here at the point P with a mass that we don't know. So it could be mg Newton force acting downwards. And it's going to start with an initial velocity of 12 meters per second. It's going to end up at the top of the slope. Again, it's the same weight acting downwards. That would be point Q, and the final velocity here will be 0. We note that it's a smooth slope, so we don't have to think about work against resistance. We are asked to find the distance travelled, i.e. distance PQ basically, which is the length that it travels. Okay, we should note from here that this is arctan 3/4. Basically, it's saying this is 3, this is 4, this would be 5 if we've got 3, 4, 5 triangles. So sine would be opposite over hypotenuse, which would give me 3/5. So the energy at the bottom of the slope, which is the point of release, will be the initial kinetic energy plus the initial potential energy. So that's going to be a half mu squared, because u, normally we say v squared, but here the velocity is 12, so we're going to use u, plus mgh. So the initial kinetic energy will be a half of m, what we don't know, times 12 squared. 12 squared is 144 divided by 2, plus mg times nothing, so this bit here will be nothing. 12 squared is 144 divided by 2, which will give me 72 joules of energy. Right, if we draw the diagram again, okay, the energy at the top of the slope here is going to be the final kinetic energy plus the final potential energy. So that will be a half of mv squared, which will actually be nothing. So it'll be half of m times 0 squared. Now the potential energy will be mg, and we'll need to calculate the height here. So that the h will be s sine of the angle. So it'll be s sine theta. This bit's nothing, so that just comes down to 3/5, because sine theta is 3/5 mgs joules. S is what we need to find. Right, by the principle of conservation of energy, and there's no friction here, so the energy at P must be equal to the energy at Q. So the energy at P was 72 m, and the energy at Q was 3/5 mgs. Now m occurs in both, so we can cancel those out. And then we can do 5 times 72 divided by 3g. So taking our calculator out, that will give me 12.24. And normally we give our answers to 3 surrogate figures, so that will give an answer of 12.2 meters. Okay, so this has been a video to show you how to find the length of the slope by using a body which has been projected upwards and the energy equations. I hope you've understood, and I thank you very much for watching.